In this video lesson we're going to continue looking at the topic of trigonometry and wave functions, and we're going to specifically look today at using the addition formulae. Now remember we talked about this at the beginning of the previous lesson, and you can see when we combine trigonometric functions which have the same period, we obtain another wave function, which we're able to express in one of the following four forms. That was k sine of x minus alpha, k sine of x plus alpha, k cos of x minus alpha, and k cos of x plus alpha. So today I want you to bear that in mind, because that will come in handy for when we need to use the addition formulae. So if we're given a function of the form a sin x plus b cos x, it's useful to express this as a single function rather than the sum of two separate functions. So that's what I've just talked about on the previous slide. Now a single function would allow us to calculate maximum and minimum values of expressions of the form a sin x plus b cos x. It would also allow us to sketch graphs more easily and also to solve equations involving expressions of this form. Now, in the previous time when we studied trigonometry in higher maths, we studied the addition formulae, and here it will help us to express sums of the two separate functions as single functions. So we should remember our addition formulae. If we have sine of a plus or minus b, that is equal to sine a cos b plus or minus cos a sine b. If we've got cos of a plus or minus b, that gives us cos of a cos b minus or plus sine a sine b. So it's really important that we're able to use these formula going ahead with this topic. So today we're just going to look at creating the equations having used the addition formulae. And then that would, after we create the equations, that would then link in with what we did in the previous lesson to solve simultaneous equations. So example 1, we want to create two equations for 4 cos x plus 3 sin x using the expansion for k of cos of x minus alpha. So firstly we need to look at k times cos of x minus alpha, and we can expand that. So we can see that cos of x minus alpha is equal to cos x cos alpha plus sin x sin alpha. And we're multiplying all of that by this k here. So that gives us k cos x cos alpha plus k sin x sin alpha. Now we can now get back to looking at our 4 cos x plus 3 sin x, and we'll notice that there are some similarities between this expression and what I have just expanded here. So we want to equate coefficients. So if we look at what each of these expressions has in common, if we look at our cos x first, and you can see that the coefficient of cos x here is 4, and here cos x has been multiplied by k and cos of alpha. So that means that k times cos of alpha is equal to 4. Now we can do a similar thing for the second expression here, and we can identify where sin of x occurs in each of these expressions, and the coefficient of sin of x in the question that we've been given is 3, and the coefficient in our expansion is k sin of alpha. So that gives us an equation, k sin of alpha is equal to 3. So just now it would be a good time to pause the video and take this down in your notes before coming back for some slight additional explanation on example 1. Okay, welcome back folks. So you can see for this example what we had been given was k times cos of x minus alpha, and we were told to use that expansion. And that gave us these two equations, k cos of alpha equals 4 and k sin of alpha equals 3. But we didn't necessarily have to have been given k cos of x minus alpha. We could have been given k cos of x plus alpha, and we would have obtained these equations. K cos alpha equals 4 and k sin alpha equals negative 3. We could have been given k sin of x minus alpha, and we would have obtained slightly different equations again. Or we could have been given k times sine of x plus alpha. And again, we could have been given slightly different equations there as well. So it doesn't matter which expansion we are told to use. We might get slightly different equations at the moment, but once we then solve for k and alpha, and then substitute back in to whatever expression we've been told to use, we would get the same graph at the end of the day anyway. Okay, so just a wee aside just now for that. So let's look at another example. We want to create two equations for 2 sine of x minus 3 cos of x using the expansion for k times sine of x plus alpha. So our solution then, again, we've been given k times sine of x plus alpha, so we need to expand that, and we know that sine of x plus alpha is equal to sine x cos alpha plus cos x sine alpha. And we can see that we're multiplying that by k, which gives us k sine of x cos alpha plus k cos of x sine alpha. And now equating coefficients, we can look firstly for our sine of x, and we can see that the coefficient of sine of x is 2, and the coefficient in our expansion is k cos of alpha. So that means that those are equal to each other, so k cos of alpha is equal to 2, and for cos of x, our coefficients are negative 3 and k sine of alpha, which means that k sine of alpha is equal to negative 3. So this is the sort of prerequisite work that we were doing just now for tackling harder problems in the wave function. So just now it would be a good idea to pause the video and before the screen goes blank and take down these notes in your notes booklet and then complete some of the assigned exercises for today.